Okay, here we go. 6, 2. We are going to multiply and divide radical expressions, and it's going to be a whole lot of regrouping. So not as much multiplying, but just knowing how to regroup to get your radicals to simplify. So first thing you need to know, things can be multiplied only if they have the same index. So this one has an unwritten index, which is implied to be 2. This one has an index of 3. Therefore, these cannot be multiplied together. These are not like, they're not the same index. So cannot be simplified. Now this one, as long as these two things are real, then we can multiply them together. So cube root and cube root, they're the same. They're both real. You can take a cube root of a negative number, so that one's good. So these can be multiplied together. So we can put the two radicands underneath the same radical with multiplication. And you'll have negative 8. And negative 8 can be rewritten as negative 2 to the third. And then the cube root and the third power will cancel each other out. So we just get negative 2. And that one is simplified. Now let's throw in some variables. Make sure we can simplify those. Okay, do they have the same index? Yes. Are they real? Yes. So we're going to put them underneath the same radical with multiplication. Now I'm not actually going to multiply them, because then I'm just going to have to factor it so that I can find a square root in it. Now I've got x to the third, x to the first, y to the second, y to the third. Now 72 is 36 times 2. 10 is 2 times 5. And then I can also rearrange this and say x squared, and that'll be x squared, because total would be x to the fourth, but then I can separate it into x squared times x squared. And then this one I can do y squared, y squared, y. 3 is the same thing as 2 plus 1. Now the reason why I've done all of that is so that I can find things that I can take square roots of. I can take the square root of 36, it's 6. I can take the square root of 2 squared, it's 2. 5 I can't take the square root of. Now the square root of x squared is x. The square root of x squared is x. Same thing with y squared and another y squared. Now the things that I can't take the square root of are this one and this one. So they go back underneath the radical. And now just tidy up this part in the front. So 6 times 2 is 12. X times x is x squared. Y times y is y squared. And we get square root of y. Now this isn't the only way you can go about it. This is just one version of it. Now if we've got division, as long as they have the same index, you can put them underneath the same radical. Simplify underneath that radical. So we've got 18 divided by 2 is 9. X to the fifth divided by x to the third, you're going to do subtraction of those exponents and you would get x squared. Can you take the square root of 9? Yes. Can you take the square root of x squared? Yes. Now, do I need absolute value? Well, it's an even index. It's an odd exponent. So yes, I would need absolute value on that one. I didn't even think about it on the problem before. Do I need absolute value on that problem before? No, because those are both squared. Anytime you square a negative, it's going to turn positive. Okay, let's see what else we have. Okay, cube root. As long as they're the same index, you can put them underneath the same radical. So let's see if anything simplifies there. 162 y to the fifth over 3y squared. I know that y to the fifth over y squared is y to the third. You're just doing subtraction there. But is 162 divisible by 3? I'm not sure. Oh yes, it is. We get 54. Is 54 a perfect cube? I don't know. Let's see. So I could do math, cube root 54. Nope, not a perfect cube. So I'm going to need to do some factoring. So 54 is divisible by 2, and I'm going to get 27. Now 27 is a perfect cube. It's 3 times 9, which is 3 times 3. So I've got 2 times 3 to the third, which is the same thing as 54. So I'm going to rewrite that as 2 times 3 to the third y to the third. Now I can take the cube root of this, which is 3. I can take the cube root of this, which is y, and then the 2 stays underneath the radical. I don't need absolute value here because that's odd, so I don't need that anymore.